Hey guys, today's video is going to be on linear regression. This is also known as line of best fit or trend line. Linear regression equation is a line that can be written for a scatter plot so that the line is the minimum distances between all of the points in the line. So it's going to fit as close to the middle of all of the points at the same time. And there is only one line that is considered the line of best fit. It takes about 2 entire pieces of paper to calculate one linear regression equation, but luckily your calculator will do it for you, so I'm going to show you those steps. The reason that we like to have this line is that it helps us make predictions about what might happen, but it is not a guarantee that it's what's actually going to happen. It's just our best estimate. So we're going to use this table here, and we're going to follow the steps on the calculator. I just want you to follow along with me as we do this. So I'm going to turn my calculator on, and the first step is to press Stat and Enter. The Stat button is right here below Delete, so I'm going to press that, and then we're going to enter to go into Edit there, and it's going to pull up our list. If you have numbers under L1 and L2, step 2 is to clear them. So you're going to go up and highlight L1, and press clear and enter, which should get rid of all of the numbers there. And you can go ahead and make sure that L2 is also clear before we start entering our data points in. I want to let you know, always L1 is going to represent your X values and L2 will represent your Y. So we're going to go ahead and enter every single point for the X values in first to L1. So I'm just going to press 0 for the first one and hit enter, and that goes ahead and puts it in my table. And then 1, 2, 3, 4, and 5. Now that I'm done, I just have to press the right arrow to go over to L2, and I'm going to enter those values in. So 5, 21, 34, 31, 18, and 3. It is very important when you complete your table that you make sure that both of these have the same number of entries. If they do not, you will get an error when you try to run your regression equation. So you have to make sure that you have the same number. So that was step 3. We entered our data into L1 and L2, and now we're going to press Stat, Calc, and 4. So we're going to press that Stat button again. It's right here. And then there's not an actual Calc button, but if you look, it's right up here at the top. So I'm going to go over to Calc, and then we want option number 4, Lin Reg, for linear regression. And you only have to press the number 4 on your calculator, and it automatically pulls it up. And enter through. On some of the calculators, you'll see this, and you'll just press enter, and it'll go. On other ones, you'll have to press enter about 5 times to make that work. And you get all of this information. You may or may not have R squared and R. We're not going to worry about that for today. We just want this. So we're going to take the value that we get for A and the value we get for B and plug it in here, where A is just M in this case for slope. And this is our regression equation. So for this, it's going to be Y equals, we typically round to about 3 or 4 decimal places. So I'm going to round to 3. So this 5 tells me that my 8 has to round up. So Y equals negative 0.629x plus 20.23238. And that is my regression equation. And so we can use this to estimate what the number might be close to for 6 or 7 or 8 or whatever. Now, before we move on and practice with this, I want to show you 2 things that your calculator can do. If I press second Y equals, so the second button and the Y equals button, this is my stat plot menu. And I can select plot 1 and turn it on just by pressing enter. And you see that how this is highlighted, that's for the scatter plot. So if I do that, I turned on stat plot 1 and then press zoom and the number 9. So zoom is here and just press the number 9. This is our scatter plot. Ignore the line that's in there. This is my scatter plot, okay? You can see how the numbers are all over the place, but that's what it looks like. So you can graph a scatter plot in your calculator. And then in blue here, if I press Y equals, clear that out, I can enter the regression equation. So negative 0.629. Remember, this is the button we use for X. plus 20.238, and then press the graph button. And that is my regression equation for this scatter plot. I'm sure you can see there are quite a few points that are pretty far away from the line. I would say this is definitely not a linear relationship at all. It's not a very good predictor of where the points actually are, but such is the case sometimes. Okay. Now that we've got this out of the way, if you have not finished writing the notes, go ahead and pause now. I'm going to move on to the guided practice. Okay. So just press clear to go back to the main screen. You can also press second and mode, which gets you to quit, which will close everything out. Okay. So we have the table shown lists the average global temperature in 5-year spans from 1957 all the way to 2016. So the first question, what is the range of the data set? Remember, range is all of the Y values. So in this case, that's going to represent my average temperature, and X is going to be my year spans. So range wants to know what the smallest to highest is. So if I look through for the smallest, it looks like 57.121 is my smallest, and it goes all the way up to 58.448. So that's my range. Then it says identify the independent and dependent quantities in their units of measure. So independent is X, dependent is Y. So I'm just going to write independent is time spans, and that is in years. And then my dependent is average temperature, and that's in degrees Fahrenheit. All right, so it says graph the data in your calculator to create a scatter plot. So to do that, we are going to press Stat and Enter to open up our table. And then I'm going to have to just go up and clear my lists, and let's enter these in. So time span goes 1 to 12. And then enter over. You're going to want to be very careful that you are entering the proper numbers and that these have the correct number of decimal points. You're putting the decimal point in the correct place. You're not skipping a number, which when I did this yesterday, I did skip a number and I had to go back and find where it was. Very obnoxious. So be very, very thorough when you do this. Okay, you can see that I have the same number of entries in both tables. And so because we want the scatter plot, I already have my stat plot is on. I am going to go to y equals and clear out that old regression equation. And then zoom and 9 will give me my scatter plot. So this is the scatter plot that represents this table. So what association do you notice? I notice that it is a positive association. As the years go by, the average global temperature is increasing. Now we want to determine the regression equation. So that's stat calc 4. I get y equals 0.12, and then that 9 makes my 5 round up to a 6. X plus 56.86, and then that 3 makes this 3 stay. So that's my equation. It says graph the regression equation in your calculator and compare it to the scatter plot. So y equals, and we're going to put in 0.126x plus 56.863 and hit graph. And look at that. This definitely fits a lot better than the first example. I would say that, yes, the line fits the data pretty well. And then the last thing, if the trend continues, what would the average global temperature be for the next 5-year span. So we made it all the way up to span number 12. So for this one, I want to know what span number 13 is going to be. So we're going to substitute 13 in for x to this regression equation. So I'm just going to write it out so that you can see what it is that we're going to enter into our calculator. Ooh, I'm writing it wrong. So I'm going to put this into my calculator. So if I hit second and quit, it'll take me back here. I can hit clear. So 0.126 parentheses 13 close plus 56.863. So that's what I put into my calculator. Press enter. And that is our answer. So if the trend continues, the average global temperature for the next 5-year span would be about 58.501 degrees. And I would say compared to the rest of this data, that seems like a pretty accurate guess.